Then we have come to the Voronoi texture. So I just skipped 2 textures, sky texture and point density, that I think will not fit into this course, and went directly to Voronoi texture. And that is what I will go through today. A Voronoi texture creates Voronoi patterns, and that is easily described if I just take this distance, put that to the base color so you can see it. And right now you can see it looks like cells here. So you have some dark spot in the middle, and then it goes out here and create edges, and that is a little bit how a Voronoi texture works. So you spread a certain amount of dots on a plane, and then it creates a small area for each dot, so then you get a straight line where these dots are closest to each other, and then that will create this Voronoi pattern. And you can use that for a lot. You can use it to create like human cells like this, or pores, or you can use it to create cobblestone or any other thing where you want to have areas that are together but in like irregular shapes. So then you can use the Voronoi texture. So what we have now as an output is the distance, and the distance is working as the length node for each of these dots, meaning that in the center of each dot here it's 0, and then you have an increasing value when it goes out from this dot until it reaches the edge here, which then have the highest value. And then it goes down again because you have a dot on the other side that does the same thing, and when they meet then you get this edge here. So that is how distance works. Color is more representing the complete area without the dot. So here you just see one static color that is randomly placed here. So it's an easy way if you want to make tiles in different ways where you only want to see the colors. You don't want the depth or you don't want the distance, just a color like this. And then we have position, and that is really good because that means that every little tile here you can extract the index out of. So you can know that if I want to work with this tile here or this area here, it's really easy for me to do some math out from this position and just do some distortion or some stuff just with this one and nothing else. And I think this is the only, perhaps there's another texture, I don't remember, that has position out. So it's a really good thing to play with if you want to do some stuff. Then we have all the fields that we can put in, and first of all the dimension that is used in most textures nowadays with 1D that only creates a singular value out depending on the W here. The 2D that is used for UV input or when you only use X and Y and no depth. And then you have the 3D, which is the normal X, Y, Z input when you also use the Z axis. And you also have a 4D where you can put in a seed to change the pattern here. So one thing you should know now is when you go to 4D, you get another output. You get a W output as well, and that will be what you can say a combination of the position on and the input you get in the W, but in grayscale. So if I change or I add a noise texture, you will see that rather easy. So Shift A, texture and noise texture, and I put that into the W here, and then we get this scrambled thing here. But here we also get what we have as a distance, so we get all the distance out and so on. But if I just want the distortion, but I don't want the internal calculation of the distance, then I just use the W here. So then I get all the distortion. You can also see that the distortion also make that the the areas now intercept each other and are not beside each other. So they are like moved all these in different positions. So it's not just changing the edges, it's changing the complete areas here. And as I said, it's a grayscale of position and color. So if I look at that, you have the same pattern here as you have here, but here you have it in grayscale. And I think it's good to use for combining with the distance to make scratches and paint that has worn off and so on. So it's a good output, even if you think it's rather simple. So that is what we have when we're working with 4D. We can go back now to 2D and look with, we can start with the distance here. And what we have below the dimensions are this list here with F1, F2, smooth F1 and so on. And F1 is the normal way to look at this, where you have this dot in the middle. F2 do some distortion to almost subdivide it, so you now have like split the areas into smaller parts, so you get more like a flowery shape compared to how it looks with F1 here. So you can see we don't have these dots anymore, but we have dark areas here, or dark edges here. So it splits, it makes an extra line here where we have all the dots placed. So that is how the F2 is working. Then we have smooth F1, which is the same as the F1, but it's smoothened out, which means that you can't see the beginning and ending between one dot and another dot, because as you can see, when you smoothen things out, then that disappears. How smooth everything should be, that you can then control with the smoothness here. So if I take it to 0, you can see that the line comes back, and then if I take it to 1, it disappeared. So that is how smoothing works, and that is good when you're doing bump maps and so on. But it's also good when you do cobblestones, because then you can create softer edges here, so you don't get these things that are rather straight all the way, so you get a softer bending here. And you do that by just combining two Voronoi textures. So you have, if I just take a copy of this one, Shift D, and I put in an input value to control, so we have the same scale on both. So Shift A, input value, like this, put that to scale here, and put that to scale here, put that to like 5, so we have something back, and change one of these to F1, like this. So we have one smooth F1 and one F1, and then I subtract those two. So Shift A, converter, math, and do a subtract. Then I just get the small difference between them. And after that, I can then just do less than or greater than here. So Shift D, and I take a less than, take this here, take that here, and then I can change this to create different types of result. And I change this to F1 in top and smooth F1 in the bottom, like this. And now let's see, so we have everything here correctly. So 2D, yeah, we need a smoothness, of course. Sorry, need smoothness. So if I now put that to 1 here, you can see that now I get beveled edges here, and then I can change the smoothness a bit until the edges go completely together. But with smooth of 1, you can see that we get a good way of making those cobblestones. So it's really good to do, and then you can just combine the distance from the F1 with the mask here to make everything pop up if you're using like a bump map or something like that. So that is a good way to use the smooth of F1. So if I just take take away that thing just a little bit. Then we have distance to edge, and distance to edge is also good to use. I will take away, subtract the less than, and just connect this to the base color, because now we get all the edges in here. So now we can use those and filter them out, so we can use a less than as well here, or we can use a map range or something like that if you just want to have the lines. So Shift A, converter, and map range, for instance. And if I just take this down here, you can see now that I get everything together, but I don't, I miss all that stuff in the middle here. So now I just get the edges. So distance to edge is really good to get a beveled edge between all these tiles here. So that's nice. Then we have n-sphere radius, and that is, if you have a dot here and you have a dot here, then you have a distance between them, of course, and that is what creates these areas. And what you get from the n-sphere radius is the distance, the half distance, so the meeting point where this line is built up, so to say. So if we just take that n-sphere radius and take it out to the base color, it doesn't impress so much because it's just a grayscale thing. And what to do with that? Well, let me show you. So if I have this Voronoi texture here, we say that it's F1, and I take and do less than on that one. So converter, math, less than, and take this in here. Can take away the map range right now, and the base color. So we have it like this, and you see that I drag this up. Then you can see that a lot of these dots here, they intersect with each other, so we don't get clear dots. Of course, if I just take down this, then sooner or later I perhaps can get all the dots to be separated, but then they are really, really small, and you get a lot of space between here and so on, and everything is in the same size. So if I want different type of sizes, I want them to not intersect with each other, then I use this n-sphere radius by just using two Voronoi texture together. So if I just take Shift D, copy this one, use this value that I used before, put that into scale here, and put that into scale here, and now use the n-sphere radius on the lower one here as a threshold, then you can see that it moves. So now we have this here, and you can see they intersect. But if I take this, it makes them smaller, so it perfectly fits inside here without intersecting, because now we know this distance between them, and the distance will, with this control here, never be so great or so big that it goes over each other. So, and if you want some space here, it's just to put in a multiply here that makes it a little bit bigger between, or you get the distance smaller. So you take Shift D to copy, for instance, multiply, and by putting this to like 0.9 or 0.8, you can get distance between them. And now you can increase the value how much you want to, and it will never intersect in any way. It will always be a distance between them that is this amount here. So you can of course play with this, put in some noise here as well. Shift A to, and then go to texture, noise texture, and put that in here, and then you have always control over that they will not intersect, but you will have different amount of distance between them as well. So it's a really good way to make a lot of dense circles together using the n-sphere radius like this. So now you know about the n-sphere radius, and I will take away a lot of stuff here and only use the Voronoi texture again. So we have this in here, can have that in, and I can go a bit closer when I've sorted everything out so you can see how it is. So this is what we have here, and now we don't have any more here. Then we have the I'm not sure how it's pronounced, but Euclidean, and that is more different types of measurement between the dots here, and that creates different types of results. So if I use Euclidean, it looks like this, and it's easy to see if I go to the color. So it looks like this, but if I use the Manhattan, then you get this type of shape instead. And if you use something called Chebyshev, then you get this type, and Minkowski, there you get a chance to, or a possibility to change things using the exponent here to make them look squared or make them look in any way using this. So by using these in different ways, you can then play with how you would like the pattern to appear. So you're not bound to have these round things. You can make them look like this instead if you want to make like cobblestones that have more corners, or if you want to make this like a town from the above or something like that. Then we have one thing left, and that is the randomness, and that is really good because with this Voronoi texture and no randomness, you get tiled patterns. So in many ways, if you take like distance to edge and put that in, then you get a good tiling already from the beginning without need to put in a lot of math here that we have done before. So you just put this to 0, and then you can smoothen things out here in different ways, and you get your tiling here. So if I just put in like a map range here, so Shift A, and then go to Converter, map range, and I just drag this down a bit like this to 0.1, then you have your tiles. So it's simple as that. Then you can even go to smoother step and even perhaps smoother step, and then it looks really, really good. So that is a way to use the Voronoi texture as well. So if you don't want irregular tiles that fits together like a puzzle, but you want regular tiles that have the same shape or squared, or if you want them round, you can then of course use them to be round here as well. So put in like Euclidean, and now you can see now you have round holes here instead that you can control in the same way as we did with the patterns here, or with the tiles that were squared before. So it's really easy to make things that are straight lines, but you need to make them repetitive without doing a lot of other math. So that is how the Voronoi texture works, and it's good for many things. So I think that normally what I use is masquerade texture and also a lot of Voronoi texture. And as I said, don't forget the position. The position is so good to use because then you have, here you can see it's clearly like a normal UV map, because you have the 0, 0 here, and then it goes up to 1, 1 here, and you can pick whatever thing you want and do some stuff with that. So if you want to color something that is perfectly just here, then you just take the coordinates from this one and you color that. And that is very useful to make a more complex pattern out of. So hopefully you have learned something about the Voronoi texture as well. And then we only have a few textures left, but I will go through them as well, and starting with the next texture in the next chapter. So see you there, and bye for now.